My wife asked me to make some organizers for a coin collection. I thought stackable GridFinity bins would be perfect. However, once I tested it, I realized that the normal GridFinity pattern would make it very hard to remove single coins. So I modified the whole grid so I could make finger holes to pop out any coin. Of course, this would not work very well with the normal 42mm grid pattern, so I just made a single grid. As I showed in my last video, making a parametric design in Fusion where equal spacing is required can be difficult, but I made a template and a parameter file that can be imported for such tasks. I will make use of that parameter file in the worksheet that I showed in the video to make this coin organizer that can be instantly modified to fit your own coin size. You might want to watch that video. I put a link below. Let's start by making the stackable GridFinity bin with only one grid. Open Fusion and start by saving and naming the file. I will call it Parametric Coin Bin. Open the GridFinity generator add-in. If you don't have this add-in, I have a few videos on installing and using that tool. Links in the description. First, click on the preview option so you can see what is happening. Next, we need the measurements of a full bin, so I set it to 5 by 5 and 1 high. The bin type should be solid. As you can see, the measurements of a full bin is 209.5 squared. Don't forget about the bin clearance on 0.25 on each side. In other words, our full bin is 210 millimeters squared. Set the X and Y to 1, and then set the width and the length to our calculated 210 millimeters. Verify that the stackability lip is checked on. The bin is looking good. Click OK. Now I want to measure the usable length of the inside of the bin. Hit I for measurement or information. As you can see, the usable length is 205.7 millimeter. This is our first coin bin parameter. Before we start adding parameters, let's verify we got what we want. Click the home view. Rotate it. I like what I see. A single large bin with a stackable lip. Now it's time to use the template from the last video. It's simpler than you might think if you saw that video. Open the parameter window and click on the import icon. Now find and choose the parameter file that was saved from that template. We need all the parameters. They're all checked by default. So simply click import. And here they are. Go ahead and size the window as you desire. Now we need to fill in the parameters that require user input. Those are the 4 favorite items. Very easy to get. The first one is length. Click I for information and check the distance between the 2 edges on the surface. That distance appears to be 205.7 millimeters. We will enter that into the length parameter. The other user input parameters are coin related. I will measure a quarter and size the holes with a bit of clearance so they don't get stuck. The quarter has a diameter of about 24.2 and a thickness of about 1.7 millimeters. I will use 24.9 and 2 millimeter respectively. Let's enter those values. The 24.9 goes into the DIA parameter and the 2 millimeter goes into the depth. And I'm pretty sure 7 coins can fit, so we'll leave the quantity alone. But we can check later. Let's take a look at the worksheet to see if we're remembering everything. We skip to the new design items, and I can instantly see where we already completed the first 3 items. It looks like we have 3 more steps with some details to do. Construction point, hole, and rectangular pattern. You can follow along with the worksheet yourself for the details or just observe what I'm doing here. Create a sketch. Choose the top surface. It helps to just click on top to get it in view. Now, don't forget to make it a construction sketch. Select point and place it on the surface. Now click D for distance and set the distance to both edges to the parameter called edge. Finish the sketch. Select the hole feature and place the center of the hole right there on that construction point. Use the counterbore type and set the extent to all so we get a through hole. Set the through hole down there at the bottom to diameter parameter for divided by 2. And then set the head of the counterbore to diameter. The height of the head is our depth parameter. Click OK. I want a small chamfer for the coin tray to make it smooth, and I want that parametric too. So enter a chamfer parameter of 0.5 millimeter in the parameter window. Misspelled chamfer, easy to fix. Make it a favorite because it's a user changeable item. Now add that chamfer to the top of both holes. We're ready for the last step, the rectangular pattern. Choose features and then select both the chamfer and the hole. Select one of the edges as the axis, and now we can input our parameters. Make sure you select spacing distribution. QTY as quantity and spacing plus the DIA parameter for distance. I want holes in both directions, so I duplicate the entries for the other axis. I think the bin is done. Let's check it. Yes, looks good. I also want to check if it's actually parametric. Let's try out some other quantity values. 8 is obviously too tight, but they line up nice. Clearly the holes are updating correctly, and my choice of 7 holes seem to work just fine. Time to save the file. You can also choose to save it with a different name by clicking File, Save As. Since I'm going to verify that I can parametrically change the coin size, let's save it as a quarter. Now I'm going to make a bin for pennies. Let's measure it. 19 about for the diameter and about 1.5 for the thickness. Back in Fusion, change the view to the top and open the parameter window. I'm just going to keep the 2 millimeters for the depth, and for the diameter I will use 19.4 to get a little bit of clearance. Let's try a few quantity settings to fit as many coins as possible without crowding them too close. It looks like 9 is a good setting. Now we just need to make a base for the trays. Open the GridFinity generator base plate. Scroll to the bottom and make the base visible. Also turn off visibility for the bin so we can see what we're doing. Now we just need to enter the 210 millimeters that we used for the bin for both the X and Y. The grid pattern to 1 by 1. And we want to skeletonize the base. To be able to screw this base into a shelf or a drawer with flathead screws, I need to reverse the screw direction. I have a couple of videos on this, so if you need more details, please see the video I have linked below. Otherwise, just follow along right here. Everything is done. Save the file again. You can name it whatever you want. If you're ready to 3D print these, just right-click on the item and send it to Mesh. I prefer to move one of the items so I can see which one is being sent. If you found this video useful, please consider subscribing to my channel. I do hope to see you in my next video.